and welcome back to AI Today. It's been a hot minute, but it's been worth the wait, I can assure you of that. What's been going on? Life. Life has been everything, and AI has taken very much a back seat in that metaphorical vehicle that is our existence. But I want it to be back, and I want us to all adventure together through what is an unending mission to understand how humans and machines can play together nicely. And one thing we've learned over the past few months is that when we give them the right conditions, machines really can give us the rewards that we deserve for our patience in programming them. And long may that continue. Today's episode is called Who Taught the Machine to Forget? A provocative title, and I think it's going to play out in the 3 acts to follow. Unashamedly inspired by This American Life. I think I cut my podcasting teeth listening to This American Life while I was a judge on the European Podcast Award a lot of years ago. So without further ado, I want you to picture a spreadsheet. Not a frightening one, just a normal, boring spreadsheet. Maybe 800 rows, columns for dates, shipping weights, invoice numbers, contracted rates per pound, or kilos if you're that way inclined. Somewhere in that spreadsheet, buried between rows 347 and rows 512, scattered across months, there's a pattern. A tiny systematic discrepancy between what a company agreed to pay for shipping and what they were actually charged. Penny by penny, row by row, week after week. For months, nobody saw it. Not because they were incompetent, not because they didn't care, but because their brains were busy doing other things, things that actually required a brain. And this pattern just needed eyes. Patient, tireless, obsessive eyes that never got bored and never needed lunch. You know, eventually, not so long ago, somebody gave that spreadsheet those eyes. And those eyes found $250,000. Today's show is about what happens when machines start noticing things. And this is the part that's going to get weird. What happens when the machines start forgetting them? I'm Dave Thackeray, and this is AI Today. Act 1, the latency of reality. Okay, you can let the spreadsheet go for a moment. We're going to talk about Rebel Cheese from Austin in Texas, the darling of the American tech community when they take their eyes off Silicon Valley. Now, Rebel Cheese is an artisan cheese shop. It's the kind of place where the cheese has opinions about which wine it wants to be seen with. They've got 15 staff. They ship cheese, a lot of cheese. And cheese, this is not a metaphor. This is an operational fact. Cheese shipping is complicated. There are contracted rates per pound, carrier surcharges, fuel adjustments, dimensional weight calculations that exist specifically to make your accountant cry. Every week, Rebel Cheese received invoices. Every week, those invoices got paid. Nobody looked too hard because the discrepancies, when they existed, were tiny. We're talking under 10 cents per pound. You'd never catch it unless you compared every single invoice against the contracted rate line by line across hundreds of shipments. So nobody did because, well, humans don't have time. Because humans were busy running a cheese shop. For at least half a year this was true. It could have been longer. The owner genuinely doesn't know how long the leakage had been happening. Because the moment you build the thing that finds it, you also build the thing that reveals how long you were blind. They built 2 AI agents. One reads the invoices. One checks those invoices against the contracted rates. Together, they produce a weekly exceptions report. Here are the overcharges. Here are the amounts. Here is who to call. The cost, this is Manus, is $200 a month. The recovery is between $1,500 and $4,000 a week. Hold that number, the 6 months, because it's going to come back. Because 6 months is how long reality was happening and the business didn't know. And here's the thing about that. It wasn't that Rebel Cheese was disorganized. It wasn't that they were bad at business. It was certain types of information have a latency problem. They exist. They are technically visible. But the gap between the signal and the human who needs to act on it is so large, so filled with other, more urgent, more human things, that the signal just sits there, getting stale, costing money. Now, let's have a look at a slightly larger company. Hapag-Lloyd, and apologies if I pronounced that wrong. Hapag-Lloyd is what, and again, apologies, 100 years old, 313 ships in their inventory, roughly the size of a small country with better logistics. Every 2 weeks until recently, Hapag-Lloyd's, product managers would sit down and manually read hundreds of customer feedback comments. They'd categorise them by hand, tag the themes, figure out what was broken. This took days. Why days? Because there were a lot of comments. 313 ships. And each one required a human brain to read it, understand it, decide what it was about, and file it appropriately, which is, and I want to be precise here, not what a human brain is for. A human brain is for deciding what to do about the fact that customers are frustrated with documentation wait times in the Rotterdam hub. A human brain is not for reading 400 comments and sorting them into categories. That's not judgment. That's information routing. You'll be hearing a lot about information routing in the episodes to come of your favourite AI podcast, which may or may not be this one. So what did the kids at Hapag-Lloyd do? Well, they built a pipeline. So Amazon Bedrock now ingests the feedback. Claude classifies it. Sentiment, theme and urgency. This is what AI is good at. And then OpenSearch indexes it. Product managers ask a question, what are our customers most annoyed about right now? And they get an answer in seconds, not days. The bi-weekly briefing now assembles itself. A cheese shop in Austin and one of the world's largest shipping companies. 15 employees, and I'm guessing rather more than 15. Different problems, different data, different infrastructure, different architecture, but the same underlying discovery. A gap between when reality happened and when it reached a human who could do something about it. And that gap was costing them. Rebel Cheese's gap was months. Hapag-Lloyd's was days. In both cases, AI closed that gap to seconds. And here's the question I haven't been able to stop thinking about since I first read both of these stories. When the latency of reality drops to zero, when the machine is noticing things the moment they happen and surfacing them immediately, does it just save money? Or does it fundamentally change what the business is capable of doing? Because I think the answer is it changes what questions the business can even ask. Rebel Cheese didn't know to ask, are we being systematically overcharged? Because asking that question required looking at data they didn't have the bandwidth to look at. Once the agents were running, they didn't just find the answer. They made the question askable. This is what I mean by the latency of reality. The information exists. The signal is there. But a business can only act on what it can see. And for most of human commercial history, the gap between what existed and what was visible to a human has been enormous. We are all closing that gap quickly. Which raises a problem I want to get to in Act 3. But first, Act 2. What happens when the gap closes in a crisis. Now, like any good series of acts, add an intermission and an ice cream. And why not? Ice cream is what makes the world go round, unless you're a polar bear. Welcome back. This is Act 2, The Crisis Playbook. But before we get started, just a quick reminder that all of the links to the stories that we mention in today's show are going to be in the show notes, whether you're Spotify or Apple Podcasts or wherever. Chances are in the description you'll find those all-important links. And if you like the show, if you feel like the show is better than it used to be, why not drop us a review on any of your favourite podcasting platforms? Anyway, advert over. Let's get stuck in. Melbourne Airport 2026. Something breaks. Not catastrophically. This is operations, not a disaster movie. But something in the infra goes wrong, and the incident response team needs to figure out what happened, what the procedure is, and what to do next. The old method would have been to search the documentation, which in a large airport is a vast, sprawling, inconsistently maintained collection of standard operating procedures. Those in the know will recognise that TLA as an SOP. Incident reports, regulatory requirements and procedural guides accumulated for decades. Somewhere in there is the relevant procedure. Finding it fast under pressure at 2 a.m. is a non-trivial problem. The new method, ask the agents. Melbourne deployed AI agents for incident response. The agents read across the documentation. They surfaced the relevant procedure, what we would call RAG, Retrieval Augmented Generation. They show their work. Here's the source document. Here's the relevant section. And here was I, the agent, think this applies. What do you think? For me, that sounds faster. It sounds more consistent, a little bit more reliable, and a little less dependent on whoever happens to be on shift, having the right institutional knowledge to know where to look. So let me introduce you to IBM's DB2 Genius Hub, because this is where things get interesting. The Genius Hub is an AI system for database management. When something goes wrong with your database, and at enterprise scale, things go wrong often, the Genius Hub doesn't just surface the relevant procedure, it can execute it. In one documented case, a database that would previously have taken hours of manual intervention to recover was handled in minutes, 35% faster time to resolution across 11,000 enterprise customers. A reduction in manual intervention of up to 10 times. The machine isn't just telling you what to do. In some cases, it's actually doing it. I want to ask you a question, and I want you to actually sit with it for a second. An airport AI agent that surfaces the wrong procedure during a runway incident. What happens? An AI database agent that executes the wrong recovery procedure on a critical system. What happens? These are not the same question. One of them has a wrong answer that you can recover from. One of them has a wrong answer that you can't. And this is the line that everyone who builds these systems is drawing right now in slightly different places. Surface the answer. Almost everyone is comfortable with this. Recommend the action. Most people are comfortable with this. Execute the action. It depends entirely on the physical consequences of being wrong. The IBM database agents operate in an environment where the worst case is a very bad Tuesday for an IT team. The governance question is, how do you make sure that Tuesday is recoverable? An airport operations agent operates in an environment where the physical consequence of a confident wrong answer is a different category of problem entirely. ServiceNow, this is like a workflow automation software platform for enterprises. I've got a really interesting answer to this. The context engine bakes governance directly into the architecture. Agents don't inherit permissions, they inherit access controls. Compliance here is structural, not configured. A partner built a production workflow using this in hours. 80% of the code was auto-generated. The humans reviewed, edited, and approved. They didn't write from scratch. That word reviewed is doing a lot of work in that sentence. Because here's what I keep coming back to. As these systems get faster and more confident, the window for human review gets shorter. Not because anyone decided to make it shorter, just because the pace of everything else accelerates and the review step starts to feel like a bottleneck. And then one day, it's not a review, it's a rubber stamp. And then one day, it's not even that. I'm not saying this is inevitable. I'm saying the pressure is structural. Speed is rewarded. Review is a cost. And the humans in the loop are the ones who have to decide every single time whether the machine's confidence is earned. This is the crisis playbook problem. Not, can the machines help in a crisis? Obviously, yes, but when the machine is confident and the human is tired and every second costs money, who blinks first? Which brings us all to Act 3, about a CEO who has a very clear answer to that question, and a group of engineers who think he's about to make a very expensive mistake. Act 3, the middle management paradox. You might have heard of Jack Dorsey. Jack Dorsey is a legend in Twitter circles. He's the guy who wrote the first tweet. He wrote an essay many years later. Yep, sounds like it's going to be a lot, but stay with me. The essay is called From Hierarchy to Intelligence, and the core argument is this. The organizational hierarchy, the management structure, the layers of middle management that most companies have, isn't primarily about oversight. It's primarily about information routing. A middle manager's job, Dorsey argues, is to take information from the people above them, translate it for the people below them, aggregate information from the people below them, and summarize it for the people above them. They are, in the language we've been using today, human routers. And Dorsey's position is that AI can replace this function entirely. That an intelligence layer, a system that can synthesize across all the information in an organization and surface exactly what any given person needs to know at exactly the right moment, makes the human router redundant. Block, Jack's company, cut 40% of its staff. His essay is partly an explanation of why. Now, I want to be fair to Jack Dorsey here because the essay is actually quite thoughtful. He's not saying fire everyone and trust the robots. He's saying the organisational structure we inherited, hierarchy as information infrastructure, was designed for a world where information moved slowly and you needed humans to carry it. In a world where information moves instantly and can be synthesised by machines, the architecture is obsolete. This is, I think, genuinely true. As an observation about what middle management often is, it's accurate and uncomfortable. But here's the part of the essay that an engineer on Hacker News pointed out in a comment that I think is one of the most important things written about AI in organisations this year. The intelligence layer that replaces the human routers is only as good as the information it's routing. And a significant portion of the most important information in any organisation, the stuff that actually determines whether the right decision gets made, isn't written down anywhere. Tacit. It's in people's heads. It's in the accumulated experience of the person who knows that the Hartman group always goes quiet in Q3 before a renewal and that quietness means something specific. It's in the institutional memory of the engineer who remembers why the system was built this way and why changing it would break something non-obvious. It's in the judgment of the manager who can tell the difference between a metric that looks bad and a metric that is bad. This is what we've been calling tacit knowledge. And tacit knowledge has a lifestyle problem and a life cycle one. Here's the life cycle problem. Tacit knowledge is created by humans making decisions and failing and learning and adjusting. It accretes over time. In a well-functioning organisation, it passes from person to person through proximity, conversation, observation. A junior employee watches a senior employee handle a difficult situation. They absorb something. That something isn't written down anywhere, but it shapes every decision they make afterwards. If you replace the human layer that was carrying this knowledge, the middle managers, the senior contributors, the institutional memory holders, with an intelligence layer before you've captured what they know, the knowledge doesn't transfer. It just disappears. And the intelligence layer, which is only as good as what it's been given, starts making decisions based on incomplete information, confidently, quickly, at scale. One developer on a forum I read described this as the 90-day rot. The idea that a company brain without active human input about what's being learned from the decisions it's facilitating will start to degrade within about 90 days. The world changes. New failure modes appear. Edge cases emerge that weren't in the original training data. And without a feedback loop, without humans telling the system that recommendation was wrong and here's why, the brain doesn't update. It just keeps making the same confident, outdated call. Well, here's the counter-argument. It's a good one. Block's intelligence layer runs primarily on transactional data. That's stream 2 in the framework that we at Word and Mouth have been using. The live performance data, the numbers, the metrics. And stream 2 has a very convenient property. It updates itself. Every transaction that happens is a new data point. The system doesn't need anyone to write down what happened. It just happened and it recorded itself. But this is very different from tacit knowledge. The SOPs, standard operating procedures, in the shared drive, the lessons from last year's difficult client, the institutional memory of why the system was built this way. That data doesn't update itself. It just sits there, getting staler until someone decides it's wrong and changes it. Maybe Dorsey is right for the type of organisation he's running. Maybe the hierarchy as routing infrastructure really is obsolete for a fintech company where the most important information is transactional and self-updating. But most operations are not running primarily on Stream 2. Most organisations run on a mixture of all 5 streams. Ask me if you want to know what they are, including a lot of Stream 1. The archive, the institutional knowledge, the stuff that lives in documents and people's heads and nowhere else. And for those organisations, the middle management paradox is real. You can use an intelligence layer to remove the routing overhead. But if you remove the humans before you've captured what they know, you don't get an intelligence layer. You get a confidence layer, which is much more dangerous. I want to end where I started, with that damn spreadsheet. Somewhere in your organisation, right now, there's a pattern that no human has time to look for. A rebel cheese anomaly, a hapagloid, gap, some version of reality that is happening and is technically visible and is not being seen. Building the system that finds it is genuinely transformative. I believe this completely. But the system that finds it is only trustworthy if it's been built on something real, on captured knowledge, on documented decisions, on feedback from the humans who noticed when it got it wrong and took the time to say so. The middle management paradox isn't, do we need humans or machines? It's, in your rush to let the machine do the remembering, are you making sure the right things get remembered? Because machines, it turns out, are very good at forgetting. They just do it confidently, at scale, without anyone noticing, until someone builds a system to catch it. Thanks a million for listening to this fresh, new style AI Today, a production by Word and Mouth at wordandmouth.com. You can check out our book all about business brains and enterprise intelligence systems. It's something that we believe is important reading for anyone in business today. So go to wordandmouth.com and check out the book there, free to read in digital format. If you'd like a printed copy, do let me know, dave@wordandmouth.com. We also have an accompanying newsletter on LinkedIn, so look up AI Today from me, Dave Thackeray. I'd love to connect with you there. I hope you enjoyed this show about a cheese shop and a 313 ship fleet. I hope that you got some really interesting insights from it, and I hope that if you've not already started building a business brain, that now's the day you do. Take it easy and be good and safe out there.